In this first problem, we ask you to evaluate a few statements on interpreters. The first statement reads, every operation can be sensibly applied to every type of value. This is not true. Let's take a look at the plus operator. If you add two strings, it's sensible that it concats them. And it's equally sensible that adding two numbers is equivalent to adding them under the plus operator. However, adding a string and a number is not a sensible operation. This doesn't really make sense what we would do with this. Do we turn string into a number and add them arithmetically? Or do we concat Uda with the 5 and get a new string? In most interpreters, this is a problem. The second statement reads, the meaning of an expression can depend on its context. This is true. At its core, this question is dealing with the notion of scope. Let me show you an example in Python. If I run this code, two values will be printed out. First 6 and then 5. Because within the function we defined x to be 6 and then printed out, the value is 6. But outside of the function, the meaning of x is 5. This implies that x, the expression just x, can mean two different things, and its value is dependent on the context it's in, whether it's in a function or outside a function, or more precisely, the scope of x. Statement 3 reads, we can use a single dictionary as an environment to track JavaScript variables. This is false. As we saw in lecture, it's necessary to use different dictionaries for different levels of scope. Here I have a diagram of one possible environment. Within a function named fun, x can equal the string Andy, whereas in the global environment, x can be the outside x string. We generally represent each of these environments as a dictionary where the key is the name of the value and the value of that entry in the dictionary is the value of the variable. Because the name can be repeated and because a dictionary has unique keys, we're going to have nested dictionaries or more than one dictionary to easily represent our environments. In theory, you could do it with a single dictionary, but also in theory, you can only use a single flat list for every program you possibly want to write. But in practice, you're going to need multiple dictionaries. The next statement reads, our JavaScript interpreter always completes after recursively walking the parse tree. This is false. The easiest way to demonstrate this is a little bit of JavaScript. Here I have a little bit of JavaScript that never terminates. Although the parse tree for this JavaScript is finite, interpreting it is infinite. The way we interpret JavaScript is by running it, and in the process of running it, we're never going to exit this while loop because the condition is true. So you may ask yourself, can our JavaScript interpreter recognize that this while loop will never finish and simply skip it, or somehow move on from it, or just terminate early? Well, although we can tell in this case that the while loop is never going to exit because it's true, and in nowhere inside the loop we change the control flow, in practice and in theory, doing this for the general case is impossible due to the halting problem, which we discussed in lecture. The last statement states, our HTML interpreter always completes after recursively walking the parse tree. This is true, because no matter what tags we use, there's no notion of a loop like we have in JavaScript. There's no recursive calls that can cause the HTML interpretation to take an infinite amount of time. Interpreting the HTML is going to be a direct function of the number of elements we have in our parse tree.